Grade 12 Physics, Light Note number 2, the two models for light. Over history, scientists have argued that light was either a particle or light was either a wave. In this note, we're going to look at some of these scientists and their arguments for why light either behaves as a particle or how light behaves as a wave. Way back in the 1700s, we're going to start with a scientist named Christian Huygens. And Huygens was a big proponent to say that light was actually a wave. He said that light was actually made up of these smaller things called wavelets. You can almost think of every point in space or every point along the line emanating out waves. These waves would just be like a puddle. These puddle waves would spread out, spread out, spread out. But if you looked at the leading edge, that would form whatever the leading edge of a wave, like a water wave coming into the shore, would be. So Huygens said that a wave is made up of smaller wavelets. Light must be something like this. Newton then came along and he said, you know what, I think that light is actually a particle, and they call these particles corpuscles. He said, just like a ball, which is a particle, if we can bounce a ball off of a wall or off of a floor, whatever angle it comes in on is the angle that leaves on. If you shine light off of a mirror, the same thing happens. The incident angle equals the reflected angle. So if a ball, which is a particle, acts like that, and light does the same, then light must be a particle. Thomas Young came along about 100 years later and did something called a double-slit experiment. This is something we're going to look at in the next note. The double-slit experiment produces an interference pattern, which is only possible if you use a wave. When we shine light through the double-slit experiment, we do in fact get an interference pattern. So this is evidence that if light produces an interference pattern, it must be a wave. After Young, James Maxwell came along in the middle of the 1800s and did the mathematics on electromagnetic fields. And on electromagnetic radiation, which we treat to be like a wave, it travels at the speed of light. So if it's traveling at the speed of light, then light itself must be electromagnetic radiation, which we consider to be a wave. So Maxwell said that light must be an electromagnetic wave. Einstein came along in the early 1900s and looked at something called the photoelectric effect. Photoelectric effect shines light on a piece of metal which bumps off electrons. This can only be explained by using the light model for being a particle. So Einstein concluded that light was both a particle and a wave, and that's what we consider light to be today, a particle and a wave.